Hello friends, this is Jim here with Science Talk. I'm going to discuss something with you I haven't talked about in quite some time. It involves the Earth's magnetic field. Will it be flipping anytime soon? The Earth's north magnetic pole is doing crazy things. It's so out of whack that scientists actually had to update the global magnetic field model a lot sooner than they usually do. They usually update it every 10 years or something like that. It was only updated 4 years ago, and they had to turn right around and update it, and they published it earlier this year, the updated version. So is this indicative that the magnetic North Pole could flip? Don't know. And by the way, this publication is called the World Magnetic Model, WMN. And it's a report that's published in Nature. And the magnetic pole is moving erratically out of the Canadian Arctic and towards Siberia. And it is moving in such an unpredictable way that it caught scientists by surprise. So Arno Schuliat, who is a geomagnetist at the University of Colorado Boulder and the NOAA, National Oceanic Atmospheric Administration, National Centers for Environmental Information, basically he's saying, okay, it's no news that the pole is moving. Long-term records from London and Paris, kept since 1580, show that the North Magnetic Pole moves erratically around the rotational North Pole over periods of a few hundred years or longer. Another researcher, Sharon Began, who's a geophysicist with the British Geological Survey and is involved in the WMM updates, basically says that, well, yeah, what is happening here was completely unexpected. And he actually cited a 1981 study from the Journal of Philosophical Transactions of the Royal Society of London in looking at the long-term data from 1580 to now. What's really catching the scientists' attention is the acceleration in movement. Around the mid-1990s, the pole suddenly sped up its movement from just over 15 kilometers a year to 55 kilometers a year, six-fold increase annually. As of last year, the pole careened over the international date line toward the eastern hemisphere. So if you want to use a compass to navigate, one of the things you have to do is you have to take into account the declination, the difference between magnetic and true and geographic North Pole, if you're in the northern hemisphere. Well, if the darn thing is moving around all over the place, that gets a little bit difficult to do. Last time I remember, the declination was something like, what was it, 24 degrees east in Alaska? Some crazy thing. It's probably a hell of a lot more. I haven't checked it lately, but it would be. So, if you're trying to do any sort of navigation, and this thing is constantly moving around, that's just going to cause headaches. So what's the chief cause of the movement? Well, it's the liquid iron outer core. And it's referred to as the core field because it sets up electromagnetic fields. Smaller factors may also affect the movement, but it's pretty much that liquid outer core. Those influences that can affect the movement include magnetic minerals in the crust and upper mantle, especially for local magnetic fields, and electric currents created by seawater moving through an ambient magnetic field. And that's according to the 2015 report of the WMM. And I did a video some time ago talking about a field associated with seawater, looking at the salinity causing it. One of the reasons, and this is a quote from Dr. Began, that we can update the map is that the European Space Agency launched a set of highly accurate magnetic field satellites in 2013. And that's referring to the satellite system called SWARM. We have a superb data set from which we can make very good magnetic field maps and update them every 6 to 12 months, Began added. We noticed that the specification of the WMM was not being met in the high latitude region around the pole, as the error exceeded 1 degree of grid angle on average. This triggered us to examine whether it was worth issuing a new update, and they concluded it did warrant such a thing. What's more is the core field appears to be weakening, which may be a sign that the planet's magnetic field will flip. According to Ronald Merrill, who is an emeritus professor of Earth and Space Sciences at the University of Washington, he says to better understand how that would happen, here's how the core field works. And he basically describes a scenario that one easy way to imagine the field is to think of a bar magnet that runs through Earth's center, has a North Pole and a South Pole, and Professor Merrill was not involved in the new WMM research. That magnet is strong, representing approximately 75% of the intensity of Earth's magnetic field at the surface. Now, obviously, the bar magnet is not a perfect representation, but it helps us visualize conceptually what's going on. It's actually electric currents that generate the Earth's magnetic field, but the model makes it easier to imagine what's going on Earth. Specifically, the bar magnet is not only moving, but also getting weaker by approximately 7% every 100 years. This is Dr. Merrill's explanations. As for the other 25% of the magnetic field, Dr. Merrill said that's generated from another field, which you can picture as another moving bar magnet. And here's an interesting bit. As the central bar magnet loses intensity, the second weaker magnetic field generates more influence on Earth's global magnetism. And that's what's causing this field to move in the direction of Siberia. So in other words, if you got the main core field weakening, there's other magnetic fields created by the currents and the minerals, and this is what's driving, according to Dr. Merrill, driving the magnetic north towards Siberia. I mean, it's not Vladimir Putin? Sorry. So Earth's north and south poles periodically swap locations, with the last flip happening about 780,000 years ago. The poles did weaken temporarily and rapidly about 41,000 years ago, this is Dr. Began, but never underwent a full flip. A 2018 study in the journal Proceedings of the National Academy of Sciences suggested that Earth's magnetic field got weaker before the big changeover. While any magnetic field flip could still be thousands of years away, the effects could be profound on technology. Right? If you have a weak magnetic field, you have less protection from the solar wind, the ions, the plasma that comes from the sun. That could affect satellites. Right? Also, weaker magnetic fields, the auroras won't be as nice. So, weaker magnetic field would be less effective at shielding the Earth from, which is the solar wind, which is charged particles coming from the sun. Also, don't forget cosmic rays. This is radiation blast from deep space, and Earth magnetic field protects us from those things. And magnetic compasses, the accuracy, not good, not as accurate. Satellites to monitor the weather or carry telecommunication signal could be disrupted or damaged beyond repair. So all these possibilities is a statement from Monica Corte, who is head of GFZ Potsdam Working Group on Geomagnetic Field Evolution in Germany. She continues to state, regarding increased radiation that would go along with decreased shielding, but it seems that the atmosphere would still provide sufficient shielding at Earth's surface that humans and animals would not be significantly affected. I guess it all depends how much decreased shielding is being referenced here. I'm a little puzzled by that statement. Let's put it that way. However, all the effects we currently only see during strong solar geomagnetic storms would likely increase and occur during moderate solar activity. This includes satellite outages or damage to satellites, increased radiation doses on long-distance aircraft, and the ISS. Let's not forget about the good old International Space Station. It's up there within, the Earth's magnetic field, because it's an LEO, low Earth orbit location, and it could be directly impacted by charged particles coming from the sun. Ongoing monitoring of the Earth's magnetic field, which includes the pole, will continue after the WMM release, principally through the European Space Agency Swarm mission, Cortez said. But she noted that measuring the North Magnetic Pole's position is a challenge. That's because the pole is located in a remote area, and the measurement of Earth's magnetic field is influenced by all magnetic field sources, including the magnetic fields found in Earth's atmosphere, ionosphere, and magnetosphere. It will depend on the future magnetic field change, which we cannot predict, if another update to the model out of the usual schedule might be required. No sooner than we thought. So, things are happening with the Earth's magnetic field. Magnetic North Pole is moving around. Is this, is the field weakening? Possibly. Will it flip? Possibly. Not anytime soon, it appears. So, but in the meantime, we do have to worry about, exposure, possible interruptions of technology. So this is important research that needs to be continued and monitored. Thank you for your time. Hey friends, this is Jim reminding you to subscribe and share my videos. Also, don't forget to click the bell so that you know when I drop a video in. And I'm also asking for you to please support the work that I do by becoming a patron at patreon.com. Details in the description box below. Thank you for your continued support.